Section 2.10 deals with a tricky topic called object references, and if you're not used to programming in any object-oriented language, this may be a little bit confusing at first. So I'm going to try to go through it a couple different ways to explain it. And this is a lesson that probably is better suited to me explaining things on the board, but I'll try to do the video version as well, and then if we need to supplement that in class, we can do that. Okay, so I'm going to show you a couple of pictures from the textbook that I just took this morning with my phone, and try to explain the concept of what we're talking about. When I create a new box object, a new rectangle object, box is the name of my rectangle. So, you know, rectangle box equals new rectangle, and then you give it the numbers. Here's what's happening. Somewhere in the computer's memory, a rectangle object is being constructed, and that means enough memory is being reserved to hold these four pieces of information, 5, 10, 20, and 30 for x, y, width, and height. And attached to that is sort of all of the reference code for a rectangle to know how to do the objects, how to do the methods that it has attached to it. And they're not all stored in the same place, but there's links to it. But the point is, the actual variable that you create, called box, doesn't hold an entire rectangle or any of the method code or any of that. It only holds a memory address for where this rectangle is actually stored. So box, the variable that we create, or my rectangle, or whatever you name it, is a very small piece of data. It's just a memory code that looks like a bunch of little letters and numbers, and it's like, 6 to 10 characters long. So it's a really small piece of data. And what it does is when the computer needs to do anything to the box object, it looks at that memory address and then finds where it's stored in memory. In some languages, you get to control exactly where something is, and you get control of this link, which is called a pointer. And in Java, you don't. It's all behind the scenes. And all this memory management of where the object sits and when it's deleted and freed up and when it's retained and held onto, all of that is managed in the background. You don't have to worry about it. And there's pros and cons to that. But in Java, that's on purpose so that we don't make too many mistakes with this stuff. So, just off the top of my head, some of the things that are useful about that is that when you're, handing around your box object to different parts of your program and it's getting copied and moved, you're only moving the memory address. You're not actually moving a big object. And there can be objects that are much larger than a rectangle, which just has 4 pieces of data. So that's one reason why that's useful. But another thing you need to know is that because of this, because you're dealing with a memory address, copying information is handled a little bit differently than it would be if you were using an integer. So let's look at the next picture to take a look at that. When I have an integer, and here's the example from the book, lucky number equals 13. The variable here actually does hold that information. It's not a memory address, it's actually the number 13. And so copies are handled differently. So if I set up a second variable called lucky number 2, and I say lucky number 2 equals lucky number, 13 gets copied in there. Not some object with 13 in it, but the actual value of 13 gets written in. So they both have the same value, but these two objects are not linked together. So then if I go and change lucky number 2 to a different value, it will have a different value than the original lucky number. Changing one doesn't change the other. But with objects, if I create a box and set it up, here's a rectangle called box, and then I create a second rectangle called box2, and I say box2 equals box, well, what that did was it copied the memory address down, not all the numbers. So basically, box is pointing at this rectangle somewhere in the computer's memory, and box2 is also pointing at the same rectangle at the same spot in the computer's memory, because the memory address is the same. That's what was copied. That's the value that got transferred. With an integer, you're transferring the literal number. That's the value. With an object, you're transferring the memory address. And so that means if I change box2, box got changed as well, because it's actually the same object. Okay, and that can be confusing at first, but I'll go through an example in the code so you can see how that works. Okay, here in the Java example, I've got an integer called lucky number. It's set to equal 13. And then lucky number 2 is set to equal lucky number. Okay? And so when we do that, we're taking the value of 13 and we're throwing it into the second number, lucky number 2. So we'll just do a quick system printout here to see what value is in lucky number and what value is in lucky number 2. All the green stuff down here is comments, and we'll go through and uncomment this in a second and see what changes happen. So I'm going to hit play, and when I do, I have lucky number is 13 and lucky number 2 is 13. So both of those values are identical. But I'm going to uncomment this section here, and what I'll end up with is a different command. We're going to take lucky number 2 and we're going to change it. We're going to say lucky number 2 equals 25. And when I do that, it's an actual change to lucky number 2. But it doesn't do anything to the original number. Just because right here I said that they were equal, I'm not linking them. I'm just saying take the 13 that's in this one, put that same number into this one. So we'll change lucky number 2, then we'll see what the new values are. As you can see, the original lucky number stayed at 13, and lucky number 2 changed to 25. Okay? All right, so that's how integers work. I'm going to block that out with a code block here, a comment block here, and we'll move into our rectangle example. And I'm doing the same exact thing. It takes a few more lines of code, but I'm doing the same exact thing. So I've got a new rectangle. Its name is box. The starting values are 5, 10, 20, and 30. And then I've got a second rectangle, and its name is box 2. And we didn't have to use the new keyword on the second one because we're just setting it equal to box, which is the first one. And what's happening here is different. What's happening here is we just copied the memory address for box into box 2. So both of these are pointing at the exact same rectangle somewhere in the computer's memory with the same exact numbers. There's not two different rectangles. These are both variables that are referencing the same exact rectangle. So if we print out the x and y values for each, we'll see that they're identical. And then if I take box 2 and I call the translate method, and so I increase x and y by 100 for box 2, you're going to see that box 1 and box 2 both got moved because they're both the same rectangle. So let me run that and we'll see the difference there. Okay. Here is the original setup where both of them are set to 5 and 10 for x and y. Box 2 got its number just because box 1 was set up that way. And then in the second example, we only called translate on box 2. But notice the original box also got moved to the exact same spot because they're the same box. Box and box 2 are the same object. But up here with the integers, lucky number and lucky number 2 are totally separate integers. They're two different variables. Okay? Hopefully that's not too confusing. It's an important idea, and we can go over that more in class if we need to. If that made sense, you should be able to handle the self-check questions on page 56.